Hello, welcome back. Hope you're all okay out there. Right, so we've had a few changes. Only two 807's, and we're running them in Class AB2 instead of Class AB1. Looked at the STC 807 datasheet with a primary of 3K4, two 807's runs, that's about the right impedance, anode to anode impedance for two 807's roughly. It should be 3.2, but it's near as hell, you know. Anyway, so the front end we've got to do that a little differently. What happens is the grids are connected direct. One moment, I'll show you this schematic. Alright, put my flag out. Hope this makes sense. So what we've got, start off with, we've got a long-tailed pair fed by a CCS, which is this one here. I've changed the anode resistors though to 62k because that's just some resistors about knocking about. That is AC coupled into some cathode followers. That's also running off a constant current sink, and then we've got this 100k pot here which is connected to the grids, and that means we can set the grids to a negative voltage so that we get minus 25 volts here on the cathodes, and then the cathodes, as you can see, are directly coupled to the 807, which are weird on the side there. So there's no grid leak resistor, no grid stopper, no coupling cap. When I did a listening test, it sounded really good, sounded brilliant. However, today, I'm going to give you a listen in a minute, but today we've got a problem. Because we've got all these constant current sinks running off this, this is 100, negative 100 volt power supply here. The winding, I only wound it for something like 100 milliamps tops, so it's struggling to supply this. The cathode followers are running at about 50 milliamps, so I need to redesign the negative power supply. So what I've got here is a big old transformer with a secondary of 90 volts, 0 volts, 90 volts. If we just use one of those windings, that will give us 127 volts ish. So if you're not sure about how to find out what sort of DC voltage you'll get, what you do is get a 90 and times it by 1.414. Now this is for bridge rectified. It's a different multiple if you're doing it half wave or full wave rectified. That gives us 127 volts. That's going to drop some when it's loaded, so we need to lose about 10, maybe 20 volts. So to find out what sort of resistor we want in here to drop that, let's say we want to drop it to 20 volts, and we've got a sort of current pull of about 0.100 milliamps. Oh, sorry, 100 milliamps. So we need something like a 100 or a 200 ohm resistor. So somewhere in here, and obviously if we've got a high current draw, 220, we've got a high current draw, we want quite a bit of capacitance on there, and I know I saved out of a power supply somewhere. 470, there you go, 470 microfarads. Right, there should be another one somewhere. What the heck? There you are. So 2 of those. Oh, there's another one. So 2 of those with a 100 ohm or 200 ohm resistor to form an RC filter should be better. And what sort of that will give us, if I can remember where I put my calculator, to find out what sort of frequency 1 divided by, I forgot the divided, 1 divided by, open bracket, 2 times pi, which is 6.28, times by our capacitance 0.1230 times by, what did we say, about, let's just say 100 ohms equals, so it will have a, basically the AC ripple 50 Hertz will be down, will be halved at around 3.3 Hertz. So that should give us a good filter. So I'll knock that up and then we'll power this up and we'll have a look. We've got a few weird things going off that I'm not quite sure how to resolve at this moment, but let's knock it up and right, it's time to have a bit of a change. I'm just going to try this A2 Class A2 operation with ultralinear taps. Don't know if it'll work. All this messing about is not doing this any good. Yesterday, while pushing the amplifier, I had a couple of bangs and magic smoke escaping. Magic smoke. Blew a diode here. Then got that sorted out, and I had something go psst over here. So I blew one of the CCS's. Blew an MJ E340. And then today I managed to track all that down, fault find it and sort it all out. And then I noticed that the output stage, the waveform was flat on one of the, on the positive going side. What the fucking hell's going off here? Looked at the bottles, looked at the output stage, you know, blah blah blah, did a few measurements and then looked at the measurement in the one on this side of the output stage. Had a look at its cathode, it was 40 volts. Hello, well it should only be like 0.4. And this is a 3 watt 10 ohm resistor. As you can see, we've got a bit of a hole in it. So I would have thought that would have been alright, wouldn't you? I mean, it should only have what? Half a volt across it. And at the most, well, at the most, yeah, at the least half a volt, and at the most 2-3 volts. Anyway, that died. I had the same problem with the other amps. I had some Vishay 2 watt 10 ohm resistors. They all went high. This one went open circuit, which is better in some respects. So right, all this pissing about is not doing it any good. So what I'm going to do, I'm going to take all this out in a minute. But before I do that, I'm going to try this autolinear tap crazy idea. Because I'm just getting to the point now where I'm messing about and just trying to, you know, doing damage and keep going backwards sort of thing, which is not good. Because I had this amplifier yesterday running really well, and then after it blew, even this morning after I traced all the faults, it's still not working right. Not as good as it was yesterday. So I'm going to try a bit of rewiring here. Have a look at that. Don't think it'll work, but let's try anyway. And then what I'm going to do is I'm going to rewire it all for extended Class A.